What happens when a preacher and a science teacher discuss today's world from a biblical perspective? You're about to find out. This is Beaker and Pulpit Podcast.
Hi, Carrie.
Hi, Christoph.
It's been a few weeks.
It has.
Yeah.
Feels like an eternity, but
You traveled a bit for Thanksgiving?
oh my, I put some serious miles on.
Yeah. So did I. It was good. A little crazy, but
Yeah.
mostly good. So,
Yeah.
well, it's nice to be back with you. Our last conversation a few weeks ago, we talked about biological complexity and diversity, and how that, in our minds, points towards design, towards a creator.
Yes.
And then also some of the probabilities of enough things going right in an evolutionary process for life to continue, not just sustain but continue. And we talked about how male and female, in terms of mammals, would have to evolve almost simultaneously
Yes.
in the same location in order to procreate and for life to continue on. And so, the probabilities of that seem pretty small.
Very.
But as we think about diversity and complexity, I came across an article that was talking about molecular motors. And so, I know this isn't necessarily molecular biology, might not be your wheelhouse, but biology is. So
Yes.
we're going to lean on that pretty heavily. But just some thoughts about, as I was reading this article about molecular motors, like even just in our eyes.
Yes.
There's hundreds of millions, even billions of molecular motors, which is crazy to think that, in the human eye, there could be that many of these things. But essentially, they are powered by ATP.
Yes. Energy.
Yep, that's the energy. And they serve a precise purpose.
Yes.
Right? They do one job or they do a few jobs, and they do that over and over and over again. And without those molecular we're talking nanoscale, right? If there's billions of these just in the human eye, that they're so precise that they perform their function over and over and over again, that they're drawing just the right kind of energy at the right time, really unnoticed to us consciously, because it's happening over and over again. And I think of this on, from an evolutionary mindset, how much had to go right for these molecular motors to exist and to perform their function. It seems impossible in my mind that, in a sense of evolutionary biology, that many things could go right all at the same time. We're talking, in the order of billions of and I guess it's really trillions in your body, but just in your eye, like 500 billion molecular motors operating at once, and they have to regenerate, right? So if we're on the order of trillions of these molecular motors in our body, that those had to evolve, not just, that one of them evolved correctly, but trillions of them had to evolve at the same rate, at the same time, in order for autonomous functions in our body to continue, for life to be sustained. And as I was reading this article, I was thinking, I don't know if improbable is the right word. Like, it seems impossible to me, but what are your thoughts on that?
Well, I think improbable would hit the nail on the head.
Yeah.
When you start looking at this, right? Billions of these things, they're carrying out a specific job. Now remember, according to humanistic evolution, we came from a pile of ooze,
Right.
okay, to somehow form a single cell organism. And now for the next 1.8 million years or billion years, whatever that they're wanting to change their scale on, we've evolved to this, and somehow all of this now works together beautifully.
Right.
And the human eye, with in the back of your eye, and a lot of people don't know this. Your pupil, that black dot that's in your eye, that's actually just a hole.
Okay.
And the light goes through it and hits the retina on the back of the eye, which is black.
Right.
And so thus, that's what you see as a black dot.
Okay.
But that retina back there is loaded with a series of what we call rods and cones.
Yep.
They're just receptor cells. And so they're taking in all of this information through that little tiny hole, right? And it goes back there, and that they're receiving this information and they're sending it just lickety split just to your brain.
Right.
Okay? And your brain can process it.
We're talking in terms of like a picosecond, which I think the best description for a picosecond that I ever read was it is the length of time that light takes to travel the width of a human hair.
Yeah.
That's how fast the information processes from your pupil to your brain. Mm-hmm. Right.
And we in fact, we don't even have computers today that go that fast.
Right.
Okay.
Yep.
So the human mind still operates faster than a computer.
Sure.
And all of that information. Now, you like basketball, right?
I do.
And I know you officiate basketball. You used to play basketball.
Right.
And I used to play basketball growing up. And to me, basketball is just a beautiful game. And when you play it right, with the four other players on your team and you all work together, it's just like a beautiful symphony.
Sure.
Okay, in my estimation, and it all works together. But you have to be able to read the entire court. Yep. I mean, if you're going to be a good player, you have to read that entire court, know where not just your teammates are at, but where all the defenders are at.
Right.
Know what each of your teammates are going to do,
what they're capable of doing,
and be able to get that ball. And as a coach, we tell our athletes, you got 1.5 seconds.
Yeah.
When you catch that ball, you got 1.5 seconds. That ball you better be passing it, shooting it, or driving it.
Right.
You don't want it left in your hands any longer than that.
Sure.
And so just think about how fast your brain has to work. You get this, and you have to know what's all going on. If you're a good athlete and a good basketball player, all that stuff is processing. Right. And so your eyes are seeing all of this. That information is going into your brain. Mm-hmm. And now you're processing it in let's say basketball language.
Right.
And now you can react to it. You know, oh, I'm going to do this give and go. And, oh, no, the defender's not going to be there, so I'm not going to give it. I'm just going to keep it and lay it in or something. And you have to think that fast.
Right.
For us to evolve from a single-cell organism to be able to think that fast and to react like that, and all of the parts and pieces, then that's just in the eyes going to the mind, let alone those signals going through your arms to your fingers, because that's you'd be down there with the ball,
sure, yeah,
to your feet so you can move.
So not just interpreting what you see, but also the nervous system.
All of this.
To do, yeah.
And it's all working together for you.
Right.
Guys, there's a designer.
Yeah.
And he knew what he was doing.
You know, I'd be curious, and there's probably someone much smarter than myself that's actually factored the probabilities.
Oh, yeah.
Because it'd be interesting to know, like, how infinitesimal is it that a single-cell organism could self-evolve into the complex forms of life that we see today. Not just human life, but, when you talk about life in a variety of species, right, we're talking about autonomous functions that benefit the life of that creature, that living organism. I saw a model of a cell, the most up-to-date recent model of a cell that was produced through a variety of different microscopic pictures, for
Yeah.
lack of a better term, right? So whether it's atomic microscopes or they're looking into the depths of the cell, and this is the most a single cell organism we think is pretty simple, but the complexity even of that single cell organism and the different functions
Oh, yeah.
that occur, autonomously, is mind blowing to me.
Oh, it is.
And to assume that evolution produced that, when by and large, when we look at not macro evolution, but when we look at micro evolutions, not adaptations, not an organism that remains that same species,
Correct.
and then adapts to a new environment. But what we're talking about, one thing becoming another. When we look at the evolution of a living thing, typically those mutations aren't benefiting that living creature, right? When there's a mutation, typically it is something that's hurt that creature or ultimately leads to its destruction.
Yeah, as a true mutation, yes. Now we'll pick on Darwin here and his Galapagos Island finches.
Right.
So here's Darwin hitting the Galapagos Islands, seeing these birds, and he was seeing the turtles too and everything else. But their beaks were different on each of the islands, right? And some of them were, and these are, we call those adaptations, but we'll also throw it in the term, it mutated. Okay. In science, we I think we truly use the term mutations extremely broad, and so when you're talking about mutations, usually lead up bad. In this case, somebody can turn around and say, "Hey, no. These mutations help these finches because they had a short, pointed beak, and so it was very powerful. So it could break open seeds. Okay, so then they can eat them."
Yeah, when I'm talking mutations, I'm thinking about something that's happening at a cellular level, or perhaps even DNA, chromosomes, right? So if it's a missing chromosome or an extra chromosome, right? Those are typically not like advancing the species, right? Those are things that are detrimental to that particular living creature. So yeah, different size beaks. I would consider those adaptations, not mutations.
Yes.
But maybe my terminology is wrong.
Well, no, it's not really wrong. It's just sometimes we'll use a broad paintbrush over it,
Right.
And we'll say, "Oh, those are mutations." It's funny because we were just down in San Antonio, and shout out to all my friends and family in San Antonio.
That's right.
And
Is it the Riverwalk? Is that San Antonio?
oh yeah, it's the Riverwalk.
been
Yeah,
there
the
once,
Alamo.
yeah.
And here it's 30 and 40 degrees. Down there it's about 75.
Right.
It's still shorts, flip flop weather and everything.
Okay.
Well, boy, we're down there, and we were just talking with friends and family, and I can't remember what the topic was, but here's my wife saying, "Oh yeah, snakes," and they have this, especially like the boa constrictors, that have like a hip bone
Oh, really?
where their appendages on each side used to come out.
Okay.
Okay, now it's just a little layer, and you can, take like a stick pointer and you can open it up and close it because it's just right here on the hip.
Yeah.
And it's right there, and
So there's like a flap.
like a little flap.
Okay.
On both sides.
All right.
Any idea what that was for?
From evolutionary standpoint, or
Yeah,
or
evolutionary.
created order.
But both. What do you think it was for?
Well, I mean, in the account in Genesis, there was a serpent that was forced to, for the rest of time, crawl on its belly, right? So legs were removed, crawl on your belly forever.
So snakes used to walk upright.
Upright, like on two legs,
Yes,
like
at
you
least.
and you and me.
Because they have the joints for that, those appendages there.
Yeah.
And so God created a mutation on them.
Okay.
So they lost that. And so now they have to crawl on their belly.
Okay. But what does evolution say? That it was one species becoming another?
They've been evolving over time. And they'll count that that was a mutation, that they didn't need those legs anymore or those appendages anymore.
Right.
So they just decide to drop them.
Do we see that? I mean, do we see that in animal life even today? That there are, a parent, a living organism that is the parent of another living organism, that the parent has certain attributes that the offspring does not?
Not really.
I mean, is it the claim of evolution that we can't see it because it takes so long for it to happen?
That would be their fallback.
Okay.
You have to understand that's their fallback. And then, it's going to take time. But they have nothing specific to point to. Now, we can point to is you probably used to have wisdom teeth.
I did.
Yeah. And they're gone today, right?
I had those removed, yes.
Yeah. And I had mine removed, and my wife and my kids and so forth. But you know what? They served a purpose at one time.
Okay.
But we don't really need them today, right? Because we keep removing them.
Right.
But you know what? They keep, every generation,
They still have them.
They still have them.
We rip them out of our face.
so how many generations have we gone when we haven't need wisdom teeth,
Yeah.
but we still have them?
Do you know what the purpose of wisdom teeth was?
Probably just an extra set of molars to help break down food.
Okay.
Because that's what, basically they're a flat molar back there.
Yeah.
And so the food that they would eat to help process it and mastize it and help to digest it. And today our foods that we eat are heavily processed and softened. And so we don't eat a whole lot of rough, coarse food anymore.
Right.
Like you probably don't eat anything rough or coarse,
Steak.
cabbage.
Does steak count as rough or coarse?
Well, I mean, let's face it. You take the steak and you want the nice steak that you can
You
cut
want
with
that
that.
tender cut, yeah.
Yeah, you want that tender cut. So,
Yeah.
so
No roughage for me.
yeah,
That's what you're getting
Yeah,
at.
you have no roughage. So
You can't hurt my feelings by poking fun at the fact that I don't eat vegetables, right? I'm good with it. I've embraced it. This is my life, Gary.
I know. But you see, that's what those wisdom teeth would be for. They'd help to break down.
So I never needed wisdom teeth. That's what you're telling me.
Yeah, but
Yeah,
but
no
it still
roughage
keeps
for me.
coming up,
They
and your
still keep
kids have
coming.
them.
That's right. Yeah.
And their kids, and it's going to keep going on.
Yeah.
Okay. So if we don't need them, then what's going to cause that mutation? Do we think about it? Or really, what triggers that mutation to say, well, I don't need those wisdom teeth no more. Let's get rid of it.
Right.
Appendix.
Yeah, I was going to ask that. I don't have an appendix because it revolted
Yeah.
and said, we don't want to be a part of your system anymore. And so I had it removed. But yeah,
Maybe that's why you don't like vegetables. I don't know.
maybe that's what it is. I didn't like vegetables before my appendix revolted either, though. But I had heard at one point that the appendix was assumed to be part of a method of digestion for raw or undercooked meats. I don't know if that's true. It was just an assumption, kind of a theory about, why we have this thing that we kind of don't really need anymore.
Well, today, some of the from health food type experts and the people who study clean eating and things like that, we really don't want to get rid of our appendix because it's there for a reason. It aids in the digestion,
Right.
and you're correct. We don't know how important it is, but we do know is that the longer we have it and the more we can keep it, it has something to do with, it ties in with our health
Okay.
to keep us healthier. And, because God's not going to create something in you that's,
I mean, it's an organ in your body.
Yeah.
It's doing something, right?
yeah. It has a purpose. So
It's kind of weird in 2021 that we don't really know the purpose of an organ that's in our body.
well, we don't know a lot of things, though. I
I mean,
mean,
that's confounding to me, right? With as much research that goes on,
oh yeah,
Yeah.
There's a lot of research goes on, but that's the thing about science. It's never settled.
right.
Okay. And so for all of you listening out there and you think certain things are settled science, somebody's lying to you. Okay. There's nothing settled in science. It is always changing. All the years that we've been studying cells, we're still
Still
scratching
learning,
the
right?
surface of it because we know some of the big processes, but we're trying to get in all the intricate details and all those. We're still learning.
Right.
So we're still learning about what the body does for each other. We know all the big things, right? The macro things, but it's all the little micro things we're just starting to learn, and we just have a long ways to go.
Sure.
And so, as a biblical worldview, you must always remember that you are wonderfully and fearfully made, and that God knows everything there is to know about you.
Yeah, and I continue to think about the precision, right? With the smaller parts that we continue to discover and understand, right? So we get to the cellular level, and the parts of the cell, even all the way down to these molecular motors. The more and more that we understand, the more complex it seems, and the precision with which it all operates. There's nothing that precise that suddenly began to exist from nothing, right?
Correct.
Aside from a designer. There's nothing in our lives that is that complex that we would look at and go, look at the complexity of that machine. It must have evolved on its own, right? The parts must have been sitting here, and somehow they came together. And we don't ever look at any complex machine that way. No. We think about the design of it, and we go, wow, I wonder how much time it took. What was the research grant? What was the process? What's R&D on this? How long did it take to put this together? Whether it's advanced weapons, or we look at the budgets of our governments for the different branches of the military, and the types of things that we look at Elon Musk or the different private companies that are launching things into space, and we go, wow, look at the process, look at the trial and error, look at the failures that have led to these successes. But we would never look at that thing being shot into space and go, it's incredible that thing began to exist on its own, and now it's firing itself into space, right? We look at the complexity of that machine, and we look at the amount of time that's gone into it, and the hundreds and thousands of people that it took to put that thing out of our atmosphere, and we go back to the designers of those things and go, what incredible minds, right? But for some reason, we look at what is even more complex in the human body or in other life, forms of life, other species, and we don't have that same sense of awe at a designer, and it's confounding to me. I've said that already once on this podcast, but it really is. It's mystifying to me that we can look at one thing that is complex and look to the architects and the designers and the engineers, and we look at something else that's far more complex and go, yeah, that thing's just been evolving for billions of years.
Yeah. It doesn't make sense, does it?
No, it doesn't. Not to me.
Yeah, you're right. It's totally illogical. There's no logic in there.
Yeah.
Because we know, the ability to take a car now and just charge it with electricity.
Yeah.
And be able to run down the road doing, 80, 90 miles an hour and drive for however long, and all the systems that are involved in that. You can sit there at a touch, while you're driving. Now I can push this button and it's going to drive itself. Okay.
Right.
Now I can play with these other buttons and see what they do and see, hey, I got this much air in each tire and and all of that. And we know that there was a designer.
Right.
because
I don't have a self-driving vehicle, and if
I don't
tomorrow my vehicle suddenly starts to self-perform tasks, I would go, "Wow, my truck evolved, right?"
Yeah,
But we don't ever see that.
correct.
Yeah,
And so you would think that over time here, we should see all of this stuff evolving. We should be seeing, even today, even in the last 1,000 years, surely we should see something that has totally really just evolved from one species to another. And
right.
where is it?
Well, and even that point of logic, if you go back to your discussion on the finches in the Galapagos Islands, you're looking at birds that have different sized beaks, but you're still looking at finches. They're all finches, right? So the adaptation hasn't changed the species. And I think that's an important point for us to understand when we have the discussion about macroevolution. The points to ponder were discussions within the framework of one species, not changing to another species, but that there were adaptations within that species.
And the idea that we call the survival of the fittest.
Right.
So, and it happens in the animal kingdom, and I guess today it doesn't happen in the human kingdom, but it does in the animal kingdom, is one animal through maybe mutation or by its DNA mixing with other finches developed a certain type of beak. Maybe it was a male, right? So now he gets to, because he's bigger and stronger, remember survival of the fittest, he's the strongest. So females are going to say, hey, let me get mated by him. Okay, and now he's going to spread his DNA, and so of that particular beak type. And then over time, he's going to spread his DNA all around, and there'll be some other females that might have some similar type characteristics and beak type as he does.
Sure.
Now their offspring come out, and so when they grow up, they become the survival of the fittest. They become the strongest. So they are going to survive better. And so they get to do more mating. That's one thing that we don't talk a whole lot about when it comes, especially to humans, because we don't apply survival of the fittest here with humans.
Sure.
It
would be immoral, right?
Yeah. And so we mate with hopefully somebody we love, right? Our spouse, right? And so we mate with them, and whatever DNA they have, whatever DNA you have, you mate, and so you're going to get that mixture in your offspring. And so that's not necessarily survival of the fittest, so not necessarily the best, let's say, of traits are being carried from one generation to the next for that particular environment.
Right.
Not when it comes to humans, but to animals it typically does.
Yeah.
And
But even so, in terms of survival of the fittest, you're talking about stronger character traits being passed generation to generation, but the species is remaining the same.
correct.
It's just a stronger version of that same species.
Yeah, and they like to talk about dogs and wolves. Well, the dogs they evolved; they came from wolves, and we see so many similar characteristics, and their DNA is extremely similar, and that's why they'll make that connection. But the one nice thing is I don't care what kind of dog you have at your house. Typically, he's not looking at you as being his next meal.
Right.
Okay, where a wolf's going, yeah, your lunch, buddy.
Yeah. I've seen a wolf in the wild once, and that was enough.
Yeah.
That thing was ridiculously huge and not anything like the domesticated dog that's in my
No,
house.
they're so strong and powerful.
Right.
More than the wolves. They run in that pack, but they run, and they can cover miles in a day.
Right.
Okay, and most of our dogs, they're humans. Walk them around the block once, and
Ready for a
we
nap.
don't know if the human or the dog is tired and needs a nap
Right.
after the one walk around the block.
In the
But
case of my dog, it's both of us. We both need a nap after we go around the block. Well, I think that's a good spot for us to pause the conversation, come back together next week. But the point to ponder, I think, is a continuation of our last discussion into this week. The complexity that points to a designer.
Yes.
The probability of the complexity sustaining life, generation after generation after generation.
Yes.
Right. The likelihood that happens by chance is infinitesimal, and that it points back towards a designer.
Yes.
And I think that it's important for us, just as we are in awe of all the different revolutionary created things in our life today,
Yes.
we should be even more so in awe of the Creator,
Oh, yes.
right? The sustainer of our life today.
Yes, most definitely.
Yeah. All right. Well, thank you, Carrie.
Well, thank you, Chris.
Look forward to next week.
Yes.